Hello friends, the presentation is on block cipher and data encryption standard. Block versus stream ciphers. Block ciphers process messages in blocks, each of which is then encrypted and decrypted. Like a substitution on very big characters, 64 bits or more. Stream cipher process messages a bit or a byte at a time when encrypted and decrypting. Many current ciphers are block ciphers. Broader range of applications. This is the diagram of stream cipher where this is the encryption process in which the plain text PI is XORed with the key KI, and the key is generated by bit stream generation algorithm, and the output of the plain text encryption algorithm is a ciphertext, and then in the decryption process the ciphertext is XORed with the key KI and the output is plain text. This is the diagram of block cipher where the plain text is of length b bits, and this is the encryption algorithm, and the key to the input to the encryption algorithm. The output is a ciphertext of length b bits, and the ciphertext is decrypted using the decryption algorithm, and the input key, the same key is used for the decryption algorithm, and the the output of the decryption algorithm is a plain text and of the length small b bits. Block cipher principles. Most symmetric block ciphers are based on a Fischl cipher structure. Must be able to decrypt ciphertext to recover messages efficiently. Block cipher looks like an extremely large substitutions. Would need a table of 2 to the power 64 entries for a 64-bit block. Instead, create from smaller building blocks. Confusion and diffusion. Cipher needs to completely obscure statistical properties of original message. Diffusion is plain text digits affect the value of many ciphertext digits is called diffusion. Confusion makes relationship between ciphertext and key as complex as possible. Fischl cipher structure. Horst Fischer devised the Fischer cipher based on concept of invertible product cipher. Partitions input block into two halves, process through multiple rounds, perform a substitution on left half data based on round function of right half and subkeys, then have permutation swapping halves. This is the diagram of the Fischer cipher structure. Here the plain text of 2 W bits of length 2 W bits, and this is divided into two parts, the left part and right part. This is the round one. The round one consists of the XOR of the left half bits and a round function, and the key is used in the round function, and the right half is input to the round function. There are total n rounds, and the last round is swapped, and we get a ciphertext of 2 W bits. This is the decryption in Fischer cipher. The decryption is just the reverse process of the encryption process. Here this is the input, the ciphertext, and this is divided into two parts, the left LD0 the left part and RD0 is the right part, and the key is the keys are applied in reverse order. That key 16 is applied first, and so on. There are also 16 rounds, and then in the final rounds the left and right halves are swapped and we get a output plain text. Data encryption standard DES. Most widely used block cipher in the world. Encrypts 64-bit data using 56-bit key. It transforms 64-bit input in a series of steps into a 64-bit output. The same steps with the same key are used to reverse the encryption. DES encryption overview. This is the diagram of the DES encryption. Here the 64-bit plain text is input to the initiate permutation, and the output of the initiate permutation is input to the round 1, and also round 1 takes the sub keys k1, and there are total 16 rounds. After 16 rounds, this output of the last round is 32-bit swapping, and this step is also called pre-output, and then the pre-output is inverse initial permutation, input to the inverse initial permutation, and then we get a 64-bit cipher text. And here right hand side the 64-bit keys input to the permuted choice 1, and the key is generated the output of the permuted choice 1 is a 56-bit key. This 56 bits key is left circular shift, and then input to the permuted choice 2, and the keys resize into a 48-bit key that is used in the each round. DES encryption overview. Processing of the plain text proceeds in the 3 phases. The 64-bit plain text passes through an initial permutation IP that rearranges the bits to produce the permuted input. The next phase is 16 rounds of the same function, and the pre-output, that is the output of the last round, that is the 16th round, is passed through the inverse of the initial permutation function to produce the 64-bit ciphertext. DES round structure. Each round of the DES uses two 32-bit left and right halves, and as for any Fisher cipher can described as the left half of the next round is the right half of the previous round, and the next half of the right half of the next round is the XOR of the left half of the previous round and a round function. The round function consists of the right half of the previous round and the key of the round key ki. The round function f takes 32-bit right half and a 48-bit subkeys. The round functions expands r to 48 bits using permutation e, and adds to subkeys using XOR, and passes through 8 S boxes to get 32-bit results. Finally permutes using 32-bit permutation P. The DES round structure. The right 32-bit is input to a permutation E that is converted into 48 bits, and these 48 bits are XORed with the 48 bits of the key, and the output of the XOR, that is 48 bit, is input to the 8 S boxes. Each S box takes 6 bits and produces an output of 4 bits. Total 32 bits are input to the permutation, and this is output of the permutation of 32 bits. Substitution boxes, that is all called S boxes, have 8 S boxes which maps 6 to 4 bits. Each X box is actually 4 cross 16 matrix. The outer bits 1, first bit and 6th bits are called row bits that select one row from the 4 cross 16 matrix, and the inner bits, the second bit and 5th bit, are called column bits that select one column of the 4 cross 16 matrix. The result is 8 lots of 4 bits, or total of 32 bits. The row selection depends on both data and key, feature known as auto claving or auto keying. This key schedule. Form subkeys used in each round. Initial permutation of the key, it is PC1, which selects 56 bits into two 28 bits halves. Thus, there are 16 stages consisting of each stage produce a subkey for the each round. There are total 16 rounds in the encryption process, and at each stage the key thus is rotating each half separately, either one or two places depending on the key rotation schedule key, and selecting 24 bits from each half and permuting them by permuted choice 2 for use in round function app total, that is 48 bit key. This description. The same algorithm as encryption, except that the application of the subkeys is reversed. The initial and final permutations are reversed. Avalanche effect. Key disable property of an encryption algorithm, where a change of one input or key bit results in changing approximately half output bits is called avalanche effect, making attempts to harm in buying guessing keys impossible. This exhibits strong avalanche effect. Strength of death. 56 bit keys have 2 to the power 56 equals to 7.2 into 10 to the power 16 values. Brute force attack is impractical, impossible. This encryption per microsecond would take more than thousands years to break the cipher. The 8 substitution tables or 8 S boxes that are used in each iteration were not made public. Thank you.